Morning, kids. So this will be Wednesday's lesson, 7.6. It's going to build off of what we did before. Now we're talking about quadratics, or trinomials that have a number on front instead of just a 1, and how we mess around with that. The first thing we always want to do is look for the GCF and see if it has one. If you notice, all three of those numbers are divisible by 3. All three are divisible by 3, because 3 divided by 3 is 1, 15 divided by 3 is 5, and 18 divided by 3 is 6. And they also all have a x, so we can say the GCF is 3x. Write that out front. Write that out front. You get 3x. And we have left behind x squared plus 5x minus 6. And that is just like what we did yesterday. So two numbers that multiply to 6, multiply to negative 6, and add to 5. We could do positive 6, negative 1. And our fully factored form would be x plus 6, x minus 1. Done. For the try it, same kind of deal. Factor each trinomial. First things first. Yeah, you know what? I'll give you a list about that, Celeste. You like that? Step number 1, look for the GCF. Look for the GCF. Factor it out. Factor GCF out, and then factor the trinomial. Factor the trinomial. So step number 1, find the GCF. The GCF is 5. Step number 2, factor the GCF out. We would have 5 times x squared minus 7x plus 10. Two numbers that multiply to 10 and add to negative 7 would be negative 5 and negative 2. Done. Second one is 30 divisible by 3. Yep. By 6. 30 divisible by 6, absolutely. Step number 1, GCF is 6x. Factor it out. We have 6x times x squared plus 5x plus 4. Two numbers that multiply to 4, add to 5. It would be 4 and 1. We would have 6x times x plus 4 times x plus 1. Done. Alright. What's next? If ax squared plus bx is the product of binomials, how are the values of a, b, and c related? So what it's trying to get you to see, is that when we have this x that we use to factor, this is going to be a times c, and this is going to be b, taken from these values. So consider the product if we distributed that using our little box method. You'd have 3x, 4, 2x, and 1, 6x squared, 3x, 8x, and 4. Get 6x squared plus 11x plus 4. And that, not by coincidence, is the same as that. So now if we're going to factor that, we're going to go the other way. We would put 6 times 4 on the top, which is 24. Two numbers that multiply to 24, add to 11. Multiply to 24, add to 11. Now the reason why we didn't do what we did last time is because this expression does not have a GCF, because 11 is prime. So now we have to multiply. Now we have to multiply the first and the last number. 6 times 4. That's how we got 24. And the middle number is what goes on the bottom. Okay. Two numbers that multiply to 24, add to 11 would be 8 and 3. And now, this is the new stuff. This is factoring by grouping. Factoring by grouping. We rewrite the expression, and the middle, we use the factors that we just found. Right here, and right here. And then rewrite the last term. So the middle changes, the ends stay the same. Okay. And then from here, we draw a line right down the middle, and we just look at the left side. So what's the GCF of the left side? Both have a 2 in common, they both have an x in common, so we factor that out. We say that 3x plus 4 is that side. Now, when you look at the right, notice that it's already the same as this expression right here. So all we have to factor out is a 1. And we have 3x plus 4 left over because we didn't change anything. And now notice that this expression and this expression are the same. And we can factor that out because that's the GCF of the expression, of the entire expression. And we can say that 3x plus 4 and 2 multiplied by 2x plus 1. Factored. Okay, so what did we do? For those of you that like to list. We found two numbers that multiply to that and add to that. We rewrote the expression and then we factored by grouping. Factor by grouping. So let's try some. I think I would learn. Factory's trinomial. Notice it doesn't have a GCF, so we have to make a little x. And we need two numbers that multiply to 30 and add to 17. Multiply to 30 and add to 17. We can do 15 and 2. Rewrite the expression. 10x squared plus 15x plus 2x plus 3. Only thing that changes is the middle term. We rewrite it using the factors that we found. And then we factor out GCF of the left and the GCF of the right. GCF of the left would be 5x. We would have 2x plus 3. GCF of the right side, just 1. 2x plus 3. Factor out the 2x plus 3. When we do that, what we have left over is 5x plus 1. So we write that here. Backward. Next, we have no GCF, so we can't factor anything out, so we have to do 2 times 21, 42. This one is negative. It has to add to 1. Add to 1. 7 times 8, 42. That's a question only a calculator can answer. 7 times 8. It's 56. Nope. 42 divided by 6. 7. 7 times 6 is 42. Bigger one has to be positive because the end result is positive. So now we factor by grouping, or we rewrite first. 2x squared plus 7x minus 6x minus 21. Draw a line down the middle. And there is no GCF. Well, there's an x on the left, so we can say 2x plus 7. There's a negative 1 on this side, and we have 6x plus 21. Now, when you get here, and these two expressions are different, we call that prime. Prime meaning that it can't be factored. Cannot be factored. How can you use substitution to help you factor ax squared plus bx plus c as a product of two binomials? Use substitution. I mean, you can try and just think about it in your mind. Two numbers that multiply to 21, add to negative 2. But why would you? I mean, you wouldn't really. I think what it's trying to get you to see is that that's prime, that this expression's prime. Because when you go here and you have, this is negative 21, this is negative 2, when there's no numbers that multiply to the top and add to the bottom, so no numbers that multiply to the top and add to the bottom, that is also prime. That is also prime. Done. Alright. One last little deal using substitution. Let's just keep using the x, because it's much more visually appealing, especially for those of you that are visual learners. So two numbers that multiply to negative 12 and add to negative 1. So we could do negative 4, positive 3. Rewrite the expression. Plus 3 minus 6. Factor out the 2x. X minus 2. Factor out a negative 3. Factor out a positive 3. 2x minus 2. No, x. Sorry, been a long couple nights. X minus 2. Factor out the x minus 2. And then you'd have 2x plus 3. Done. Same deal. Different color. Two numbers that multiply to negative 10. Add to 3. 5 and 2. Where the 5 is positive. 5 is positive. 3. 2. 2 is negative. And then rewrite. 10x squared plus 5x minus 2x minus 1. Factor out of 5. X. You're left with 2x plus 1. Factor out a negative 1. You're left with 2x plus 1. And factor out the 2x plus 1. And you're left with 5x minus 1. Done. Alright, here's your list. Stuff is due on Friday. We do have a quiz on Thursday. There is a quiz on Thursday. So yeah, good luck. Hope you have a wonderful day. Hope you're staying warm. See ya.